Hello everyone, let's provide the solution given this nice exponential equation, which is 8 raised to power x plus 1 minus 8 raised to power x minus 1 is equal to 63. So this is the value of x. Solution. So you have that 8 raised to power x plus 1. In fact, x plus 1, this can be expressed as x minus 1 plus 2. Okay, so we substitute x plus 1, which is x minus 1 plus 2. So we can do that so that we'll have 8 raised to power x minus 1 plus 2 subtract 8 raised to power x minus 1. This is equal to 63. Okay, now as you can see, 8 raised to power x minus 1 plus 2 is in the form of a raised to power n plus m, which you can transform to a raised to power n multiplied by a raised to power m. Okay, so from there we're going to have 8 raised to power x minus 1 multiplied by 8 raised to power 2 subtract 8 raised to power x minus 1. This is equal to 63. Now as you can see, 8 raised to power x minus 1 is common, so we factor out 8 raised to power x minus 1. You will have 8 raised to power 2 subtract 1. This is equal to 63. So we'll have 8 raised to power x minus 1 into the bracket. This is 8 squared, which is equal to 64. Subtract 1. This is equal to 63. Okay. Now from there, we will have 8 raised to power x minus 1 multiplied by 63. This is equal to 63. We divide both sides by 63 by 63. Okay. So that we're going to have 8 raised to power x minus 1. This is equal to 1. Okay. Now from there, as you can see, we have 8 raised to power x minus 1, which is equal to 1. Okay. But you find that if you have a, there's a property that if you have a indices property, if you have a raised to power 0, this is equal to 1. Okay. If you have a raised to power 0, that gives you 1. So we can just have 8 raised to power 0. This is also will give us a value of 1. Okay, so we're going to have 8 raised to power x minus 1. This is equal to 8 raised to power 0. Okay, but now if you're given a raised to power n, this is equal to a raised to power m, and given that bases are common, then the powers also are equal. That is n is equal to m. Okay, so that means if you have this, in our case here we have 8 raised to power x minus 1. This is equal to 8 raised to power 0. Okay, since the bases are common, you just have the powers, which is x minus 1. This is equal to 0. Okay, so that means that x is equal to 1. Okay, so let's verify if this value of x satisfies the equation. Okay, so let's verify. We have that so let's verify that actually the value of x, which is equal to 1, satisfies the equation. Now as you can recall, we end at 8 raised to power x plus 1 subtract 8 raised to power x minus 1. This is supposed to give us a value of 63. Okay, now substituting the value of x, which is 1, we are going to have 8 is equal to 1 plus 1 minus 8 raised to power 1 subtract 1. This is supposed to give us a value of 63. Okay, so we're going to have 8 raised to power 1 plus 1. This is 2. This is 8 squared. Subtract 8 raised to power 1 minus 1. This is equal to 0. This is supposed to give us a value of 63. Okay, now from here we have seen that if you have a raised to power 1, this is supposed to give us a value of 1. Okay, so if you have 8 raised to power 0, this essentially is supposed to be equal to 1. Okay, so applying this property, you find that we're going to have 8 squared. This is equal to 64. So we're going to have 64 subtract 1 is supposed to give us a value of 63. So 64 subtract 1 is 63, which is equal to 63. Okay, so that shows that x which is equal to 1 satisfies the equation. So thank you for watching, and if it's your first time to watch my videos, kindly consider subscribing. Thank you.